Hello everyone, after having completed the first law of thermodynamics, now time to discuss the second law of thermodynamics. We have so far discussed the zeroth law and the first law. Now the second law of thermodynamics and its physical significance in lecture number 20. Before devising the second law of thermodynamics, we have to know why the second law was needed. The need for the second law, and the need for the second law is actually hidden in the failure of the first law of thermodynamics. So what about the failure of the first law? The drawbacks of the first law of thermodynamics is that it does not indicate whether a transformation of energy would at all occur, and if it occurs, then to what extent or in which direction would that occur. So that is the need of the second law. Second law can fulfill these requirements. That means if some thermal flow, some heat is flowing from one body to another body, first law, what does the first law say? First law says that the total heat is constant, or total energy is constant. But it cannot say whether the heat would flow from one body to another body. And if it flows, then in which direction would that flow? The first law cannot say that. First law only says their constancy, the constancy of their summation. But the second law can fulfill these requirements. Now, before moving on to the second law of thermodynamics, we have to have idea about the perpetual motion of second kind. We can recall the perpetual motion of first kind before the first law of thermodynamics, and in reality that machine was not possible because it could produce some work without being aided by some external energy. No, that's not possible. Now let's see, what about this machine? A machine which can continuously take up heat from a reservoir by cooling it and convert it partly or fully into work is called the perpetual motion of second kind. So is it possible? No, in reality this is not possible. There is some body and it must have some heat energy in its body, and you are taking up that heat and converting into work. Is that possible? No, in reality that's not possible. So let us see, what does the second law say? It is impossible for a self-acting machine, unaided by any external agency, to convert heat from a body at lower temperature to a body at higher temperature. For example, suppose take the example of refrigerator or air cooler. Take the heat energy inside the refrigerator, or absorb the heat energy inside the room, okay, and there is no electricity. External agency is not present there, okay. So without electricity, is it possible to take up the heat? The answer is no, and this answer is the second law of thermodynamics. So it is, again, I just repeat this. It is impossible for a self-acting machine, unaided by any external agency, to convey heat from a body at lower temperature to a body at higher temperature. Okay, this is not possible. So what about its physical significance? Okay, it has a very important two physical significances. Heat cannot pass spontaneously from colder body to a warmer body. That means the second law says that if there is no temperature difference, heat cannot pass from one body to another body. And if there is temperature difference, heat can pass. But in which direction? The heat would only pass from the body at higher temperature to the body at lower temperature. This is the physical significance of the second law of thermodynamics. So this is the first physical significance. And the second physical significance? The second physical significance of the second law of thermodynamics is the entropy of the universe tends to be maximum. So what about entropy? Entropy is the degree of disorderness. This term will be discussed with more elaboration in the next lectures. Now, spontaneity of a system, or what about a spontaneous process? The changes that take place automatically in a system without the aid of any external agency are termed spontaneous process. This action is unidirectional or irreversible. That means it takes place in one direction only and doesn't come back. So this is found to happen in case of irreversible process. Remind the difference between reversible process and irreversible process. In one point we have mentioned that the irreversible processes are unidirectional and spontaneous. So this spontaneity has also a significance in discussing the second law of thermodynamics, because suppose two bodies are there which has temperature difference. So heat will spontaneously pass from the hot body to the colder body. So this is a spontaneous process. That is why spontaneity of a system is very important when discussing the second law of thermodynamics. Now what about efficiency? So there are two bodies, one is source, another is sink, and source has temperature T1, sink has temperature T2. Okay, then in such a way that T1 is greater than T2. So this is the hotter body, this is the colder body. So definitely heat would pass from the source to sink, and in between, if some machine is connected, then it is placed in path of the heat transfer, then that machine would produce some work, and that work is minus W, the work done by the system. Okay, and in that case Q amount of heat is released by the source, and some of this heat is converted into work, and the unused heat is deposited in the sink, which is Q dash or Q prime. Okay, so if Q amount of heat is released by a source at temperature T1 and Q prime amount of heat is taken up by the sink at temperature T2, where T1 greater than T2, then the work done by the machine, which is placed in the path of transformation of heat from the source to the sink, is Q minus Q prime. And the efficiency, so what is the definition of efficiency? Efficiency is the ratio of work produced and heat supplied. So what the work produced is minus W, and the heat supplied was, this heat was supplied, but not all of it is converted into work. Some of this heat is deposited back into the sink. Okay, and Q minus Q prime amount is only converted into work. Therefore, minus, instead of minus W, we can also write Q minus Q prime. So this is the definition of this is the mathematical form of efficiency. Okay, and now the mathematical form of the second law of thermodynamics. But before that, we have to go to the Carnot cycle, and afterwards we shall have the idea about entropy, and then the mathematical form of the second law of thermodynamics. And the link of the next videos are definitely given in the description box below, so don't miss the next few lectures on entropy, Carnot cycle, and so on. Okay, so thank you, have a nice day.